Hey guys! Today we're going to be going over the last 2022 AP BC Calculus answers, and let's get started into the video. Just a quick reminder that you can access these questions in the official PDF, which I have linked in the description box down below, or you can copy the link in the video shown right now and put it into your search bar. Just wanted to also mention that this is not affiliated with the AP College Board. This is just a video going over all the answers, which we'll do right now. First is question 6A. Apparently, this FRQ had less than 1% of students earning perfect scores, and I completely understand why. This was definitely a harder one. So, question A asks us to use a ratio test to determine the interval of convergence for the power series. To start, we can find the limit as n approaches infinity, and then in absolute values, the setup will look something like this. Now for the first fraction, it's going to be substituting all n's for n plus 1 into the general term, so it would be a negative 1 to the n plus 1, and then x to the 2 times n plus 1, which is 2n plus 3. And then it would also be a 2n plus 3 on the bottom. For the second fraction, it'll be just the general term but flipped, so whatever is on the bottom is on the top, and whatever is on the top will be on the bottom. Now we can start by crossing off things that will cancel. First, because this is in absolute values, we can just cross off the alternator because it'll end up being positive. We can also cross off the 2n plus 1 and the 2n plus 3 because when you take the limit as n approaches infinity, it will have a limit of 1. And so we're left with x to the 2n plus 3 and x to the 2n plus 1, which you can simplify. And remember that you can subtract exponents and fractions, so 2n plus 3 minus 2n plus 1 will just leave you with 2, so we're left with an x squared. And then to get rid of the absolute value, you can make the x squared greater than 1 and then less than negative 1, and the square root of 1 is just 1. So now we're not quite done yet because we need to check endpoints. So I'm going to make a new page and we're going to check x is equal to negative 1 and x is equal to 1. We can substitute the x in for negative 1, and so if I find that value, it'll be all of this, but replace the x with a negative 1, and if you combine the negative 1's on the top together, the n and the 2n plus 1 will add to become 3n plus 1 as an exponent. Now, we want to check if this converges or diverges. Well, because there's an alternator at the top, let's see if this converges by the alternating series test. This test will determine if a series converges if and only if the terms decrease in absolute value and the limit as n approaches infinity is 0. And it needs to be both of these. So I'm going to plug in values for n, like 0, 1, 2, etc., and see if the terms decrease in absolute value. So plugging in 0, it'll be a 1 over 1, or a negative 1 over 1, or just negative 1. And if I plug in a 1, it'll be a positive 1 on the top and a 3 on the bottom. Plugging in a 2 will be a negative 1 on the top and a 5 on the bottom. And this will just keep going, but just to see the general trend, the terms are decreasing as long as you add in those absolute value bars as well. And so we can check off that yes, the terms will decrease in absolute value. Now let's check if the limit as n approaches infinity is 0. I'm going to take the limit of the general term with negative 1 plugged in, and then if I plug in infinity on the bottom, it'll be a 1 or a negative 1 divided by a super big number, so a small number divided by a super big number, which that will be a 0. So yes, the limit as n approaches infinity is also 0, and so by the AST, this series will converge. Now let's check x is equal to 1, so I'm just going to put the sigma with infinity and the n equals 0 on the bottom of the general term as with 1 as x. And then combining the top will be a negative 1 to the n because the 1 to the 2n plus 1 power will always be a 1, and the negative 1 to the n will stay. Now because there is also an alternator, let's do the AST again. So let's plug in numbers to see if the terms decrease in absolute value. Plugging in a 0, it would yield a 1. If I plug in a 1, it would be a negative 1/3 and then a positive 1/5. And again, this will keep decreasing as long as there are absolute values. So it does work. And then now let's check the limit as n approaches infinity and to see if that equals 0. And it will be 0 because it is a small number on top of a super big number. And finally, we can conclude that this does converge by the AST. Now going back to the previous page, after we checked endpoints, we found that both will converge, so it will be less than and greater than equal signs for both. Now let's do the points. I think it'll be a point for the setup, and going on to the next page, it'll be a point for considering both endpoints. And also, when you're considering both endpoints, make sure to restate everything and say that it does converge by the AST. Okay, and then the third point will be getting the correct answer. And so technically, if you didn't check endpoints correctly, like if you didn't get that it converges, you can still get the point just because you even considered checking endpoints. However, you will lose the point if you don't get the actual correct final answer. So again, you will get the point if you considered checking endpoints, but you won't get the point if you checked the endpoints wrong, if that makes sense. Now for question 6b, we need to show that f of 1/2 minus half is less than 1 over 10. So here is the original series, and we need to find out if I can use the alternating series remainder or the Lagrange remainder. Obviously, the alternating series one is a lot easier, and I hope I can use it on this one. So I can use an alternating series remainder if the alternating series converges. Well, this is an alternating series, and well, does it actually converge? Well, the terms do decrease in absolute value, and if we take the limit as n approaches infinity of the general term, then it does equate to 0. So we can make sure that it does. So this does converge by the alternating series error. And so, by definition, for a converging alternating series, we can find the error, which will always be less than or equal to the absolute value of the next term, or the first unused term, after the first term, which is the negative x cubed over 3. So I'm going to take the error, which I stated above, has to be less than or equal to the absolute value of the next unused term, which is the absolute value of x cubed over 3. And because it's asking for f of 1/2, then I'm going to plug in half as x, which if you do so will be simplified to 1 over 24, which is indeed less than 1 over 10. And that's pretty much it for this one. For the points, I think it's going to be a point for noting that the error will be less than the next unused term, and the other point will be plugging in the half into the first unused term for it to be less than half. And that, I think, is going to be a good justification for this question. And for part 6c, this one asks us to write the first 4 non-zero terms for f prime of x. So as a reminder, here is f of x. And to find f of x, you would just simply differentiate it to go forward to f prime of x. And to do that, you just want to take the derivative of each single term. And then so the derivative of x is just 1, and then minus the derivative of x cubed divided by 3, which is just x squared. And this one, as well as the next two terms, will have super clean derivatives, and it looks really nice. And then you're just going to add the next derivative, which is x to the 4th minus x to the 6th. And now that we have 4 non-zero terms, we also need to find the general term. Well, the first thing I noticed is that this is an alternating series, so it has positive and negatives, and it keeps alternating positive, negative, so it will need to have a -1 to the n power. And then the exponents for each x are even, so that's going to make this an x to the 2n. And that's pretty much it for part C. Okay, and then it's going to be a single point for the first 4 terms, and then another point for the general term. And lastly, on part 6d, we have to use the result from part 6c to find the value of f prime of 1/6. Here is our f prime of x that we found in part c, and we want to find an accurate summation of this. And we can't just plug in 1/6 because not all the terms are shown, so one thing that you can do is you can find the sum, because this is a geometric series. We can find the sum of a geometric series, if you remember, and we first need to find out what our r value is, or our ratio of each term that's being multiplied. So to get from 1 to a negative x squared, and from an x squared to an x to the 4th, and an x fourth to an x to the 6th, each time we're multiplying by negative x squared. And so my sum will be equal to a 1 on the top by definition, and on the bottom it will be a minus r, where a is the first term, and that is also a 1, minus the ratio, or negative x squared, and we need to find f prime of 1/6, so just use the sum and plug in 1/6 as x, And you honestly don't need to really simplify this. This technically gets to the point. I decided to simplify it just a little and leave it as 1 over 1 plus 1 over, 1 over 1 plus 1 over 36. And I think it's just going to be a point for finding the ratio and another point for finding the correct answer and plugging it into the formula. I don't know if these point breakdowns are helpful or if they're very accurate, but kind of gives you an idea of how many points all these questions are worth. And that is the end of FRQ number 6, as well as all of the BC Calc FRQs. We finally made it to the end. These scores are my own predictions of what you might need to get at least a 3, and my score predictions for a 4 or a 5. Now note that these are not the official scores that you need to get, but I've kind of formulated my own based on previous years. Also, quick update that the AP College Board has already revealed all the score distributions. They usually do so 2 weeks prior to the score release date, which is July 5th this year. And so if you go on to Trevor Packer's Twitter, you can see all the percentages of who got what score for which test. Here are just some score stats for the AP English Language and Composition exam, which, by the way, if you want to know the answers to, check my video. I do have a video on that. And there are also scores for the AP Calculus AB scores. And he also has the BC Calc ones, which is awesome. We improved by 2% this year. I'm super happy. So yeah, be sure to check out the distributions. And yeah. And thank you for watching my video. Be sure to give this video a huge thumbs up, subscribe if you learned something new, and comment if you have any questions. Also, if you took the AP language test and want to know the answers, then check out the video to the left. If you want to know the answers to FRQ number 5 for the BC Calculus test, then you can always click on the video to the right. Thank you so much for watching. Be sure to stay tuned for my upcoming videos, and I hope you have a fabulous day.